Hello, we are going to be looking at doing algebraic proofs today. In particular, we're looking at a type of proof called two-column proofs. And notice here that I happen to have two columns, hence the name. Statements is the name of the column that we will have on our left. Those are the things that we're claiming. Those are the steps basically in this case, solving algebraic equations. On the right are the properties of mathematics and algebra that we are able to use to explain why we can do these steps. Everything we do, there must be a rule for. Just like in Monopoly, you can get to Boardwalk if you roll so that you go onto it or you grab a card that says go there. But you cannot just arbitrarily just say that I want to go to Boardwalk and place yourself there. You need to be able to get there within the rules. Same thing in math, you need to be able to get to your result with the rules. So this is set up a little bit different than you might be used to. You are given an equation here. In this case, it is 8x minus 4 equals 20. And you're also given what the solution is for x. Quite often you have to solve for this, but in this case, it's given to us. That's weird, but there's a reason for this. We're given this so that we can justify all of our steps of how that is true. A solution is great, but you should always be able to explain how you reached your solution, and we will do that here. So the first thing in any two-column proof is you have to put down your givens. In this case, we are given this equation. And my justification, the reason that I'm putting it here is that this is given to me. Always, always, always. You always are given your first step. If you don't have this, you have nowhere to go. You've got nothing to work from. So given is your first step. So my second step. Eventually at some point, this x equals 3 is going to be down there somewhere. But how do I get there? So I'm going to start solving this like I normally would, but I'm going to be very particular about putting every individual step here so that I can justify that with the properties of algebra, and in particular some of the properties of equality that we've looked at. So if I was to solve this, I know I need to do inverse order of operations. I need to kind of start from the back and work my way forward. I need to get rid of this negative 4, this minus 4 if you will. I can do that by 8x minus 4. The opposite of subtracting 4 is adding 4. I do that to the left, but I have to do that to the right as well. And I can do that through, since I'm adding, the addition property. Quite technically, the addition property of equality. If I add something to the left, I need to be able to add something to the right. It's kind of like a scale. So if I put a block over here on the left, I need to have a block over here of the same size on the right. And let's just pretend those are the same size. My drawing skills are not fantastic, but I think that's close enough. It's representative. That you must have that equality. If you add something to one side, you must have it on the other. Okay, so I have that. My next step here would be to, we've been saying simplify, but really what we're doing is we are substituting. And so my justification for this is the substitution property. Substitution property. Okay, this is the same thing. This 8x is this equal to in value 8x minus 4 plus 4. Why? Because these negative 4 and the positive 4, they cancel each other out. So both of them are equal to each other. That's how we're able to swap out this up here with that. Same thing over here. 20 plus 4 is the same thing as 24. So we are substituting in the simplified value in order to get something that's really just easier to work with. And we move on. Numero 4. I want to isolate the variable. I've got 8x. I divide on both sides by 8. What property do you think we will use to justify this operation? The division property. I'm dividing on both sides. That is okay. I can do that. As long as I'm doing the same thing to both sides, I can divide by whatever I wish. The one exception being 0, because that you can never divide anything by 0. But anything else, 1,512, 62, 42, whatever I wish to divide by. Now, my last step here, I have x equals 24 divided by 8 is 3. And hey, check it out. That's what our goal is. Oh boy. X equals 3. So this is going to be my last step, since once I justify this step, then I've proven it, whichever one that may be. I'm just plugging in 8x over 8 is the same thing as x, right? Because those two things cancel. I'm substituting here again. So substitution property is what will wrap that up for us. Again, I have proven that x equals 3. Every step I've justified. That's why it all makes sense. That's how I know this to be true. I've proven every step along the way. Let's do another one here. This one I want you to work along with me, to speak out, if you will, what these are. You can say them out loud. I don't think anyone is listening. You know, look around. No, okay. Okay, all right. Maybe someone is listening really quietly. Maybe you can just, like, you know, mouth this one or like whisper it or something like that. It helps. It's like a communication thing. It's like brains. They're weird. They do that. So, first thing first, here is the equation. I've got x over 3 plus 4 equals 7. I want to prove that x equals 9. I've got something already here in the statement. This is exactly what's up here. So what do I put down as my first justification? Survey says should be given. Always, always, always. First thing is given, just like we said moments ago. Next step, x over 3 plus 4 minus 4 equals 7 minus 4. Which property do I use now to make this change from here to here? Subtraction property. Because I'm subtracting on both sides, and this is the rule that says that's okay. I can do that. Now I've got x over 3 equals 3. What's my property? Substitution. Again, I am substituting x over 3 plus 4 minus 4 has the same value as x over 3. They are interchangeable. 7 minus 4 has the same value as 3. They are interchangeable. I can swap those. Alright, now I'm missing some of the statements on the left. let's see what I can do here. I'm using the multiplication property of equality. We haven't been saying that a whole lot there, but that's implied. So if I'm using the multiplication property, what operation am I going to be doing on the left? Well, I would be multiplying. Multiplying by what? Let's multiply by 3. Why 3? Well, if we multiply by 3, then the 3 in the numerator here, because this is technically 3 over 1, 3 is the same thing as 3, right? Times 1 over 3 equals 1, and 1 times anything is itself. So those will successfully cancel out each other. And then I'm left with my last thing. Think about it for a moment. What can I put here? What are we trying to prove? That's our goal, x equals 9. And hey, that works here because I have on the left x, 3 times 3 can be substituted, hence substitution property, with 9. There we go. We are all set. All right. I hope those were some good examples here and they made sense. I want to give you one to work on before we gather back together. So, given that 5x plus 2 equals 32, you want to prove that x equals 6. Your statements, your conclusions. Fill in the blanks here. Bring your questions. Let's see how this goes. Do your best. You are awesome. You can do awesome. Have a fantastic day.